Hi everyone, good morning. Welcome to COMP1531. It is so good to see you all this morning. I think we have how many people tuning in? We have 241 people in this lecture, which is an exciting way to start the term. I can't stress enough how excited I am for T3 with you all. I know you might be tired at this time of year. I know that students sometimes get quite exhausted towards the end of the university year, but we're going to try and make it quite fun for you. And we'll get stuck into it pretty quickly this morning. So, firstly, quick introduction. My name is Hayden. I am one of a teaching staff of about 40 people that will help take you through this course, and one of a few key people helping run it. So we'll get stuck into that now. So, for those of you who've joined in, I assume by now that you've already seen WebCMS 3, which appears to currently be down. I've just been trying to upload. I don't know if it's down, but I've just been trying to upload some new lecture slides, and they have been failing for a little while, and the website's not loading. That's not going to slow us down, but nonetheless, most of you should have seen it because that's where this lecture link is. So I'm assuming by the fact that you're here, you have access to WebCMS 3. If you're watching this lecture because you have a friend who's doing the course who kind of gave you a link to it or something like that, then that is fine too. If you don't have access to WebCMS 3, you will get access tomorrow. Basically, you get access the day after you get enrolled in the course. That's just how the CSE systems work. Regardless though, we're just going to be going through some slides today. We're going to be talking a little bit about the course as an overview, then we're going to be going straight into learning about Git, which is a pretty pivotal tool in the course, and it's also a big part of your first lab. And then after, that's the wrong link, damn it. And then after that, we'll be doing a little bit of Python. I think we'll be doing all of Python tomorrow, lots and lots of Python, and today we will be maybe doing a little bit of Python, I'm guessing, given how the timing of things is going to go. So let's, I think WebCMS 3 looks like it's back. Well, it seems to have been back on another tab I have over here, but maybe not yet. That's okay. We don't need it right now. So to get stuck in, this first little lecture, right? Lectures in this course are typically about 40 minutes in size, and we do 2 or 3 of them per 2-hour lesson, I guess. And the first one we're going to be talking about is just software engineering and the course as a whole. You know, what is this whole thing? Why does it matter? Everything like that. So the big question to always start with, right? You know, start with the why kind of thing is, why does COMP1531 matter? Now, I can't ask you the question, why are you doing this course, as if you have some intrinsic meaning, because most of you are doing it because your UNSW program says that you have to do it. So you're not really here by choice. Some of you, I'm sure, are excited, but most of you are here because you've told to be here. And I want to dig into a little bit about why this course should excite you, because I've been involved with quite a lot of courses at UNSW, in particular in computer science, and I can confidently say that I think this is, or at least this can be, the most important course as part of your development. I can't guarantee you that it is, because everyone's different and there's no guarantee that we do a good job, but regardless, it's something that really should be. So why does this course matter? COMP1531 is the opportunity where we can take you from a solo programmer and turn you into a collaborative software engineer. So that by the end of this course, you aren't just someone who can code, which is kind of, you know, practically where many of you are at this point, having done 1511, but you're someone who can work in large software projects and build a larger scale software system. You're someone who has the skills to manage and work with a group of people rather than just doing things by yourself. And as a bonus, as part of this course, we get to teach you how to be familiar with Python and a bit of web applications as well. So there's a little bit of fun in the course in terms of hard skills, but Python, web stuff, that's all just kind of there to help teach it. We do go into a lot of depth with Python, but fundamentally, this is about helping you go from like a little C file that you had on your computer to thinking bigger, thinking about how software systems need to be begin and end, and think about How do we figure out what we're building? How do we think about building it well? How do we actually build it? How do we make sure it's working? And then how do we release it to people so that they can use it? And that's what we call a life cycle of software engineering. And that's something we're going to be digging into a lot. So the way I often phrase this to people is that, you know, COMP1531 is not the course that will turn you into a brilliant software engineer. It is the course that is the very first and most pivotal step in that journey. So when you look back in 5 years, what we want to see from this course is that you are like, I remember 1531. It's where I learnt the first little bit of the most important stuff that helped dictate a lot of what happened afterwards in my career, however that pans out for you. So in terms of the core content we teach in this course, it's really broken up into 4 big categories. The first one's software engineering and the software development lifecycle. That's the kind of theory around, you know, again, what is software more than a program? Because, you know, you can imagine it, big companies like Google and Facebook and Microsoft, they're not sitting around just talking about code all day. They're talking about systems and processes and planning and operations and, you know, design structure. They're talking about much more than just what a programming language can do. And that's what we're going to be digging into. That's the most fundamental part of the course. The second part of the course I mentioned is Git, project management, teamwork. You can actually apply a lot of the principles of the software engineering lifecycle and software engineering in general by yourself, even if you're just a one-person team. But in reality, most things that happen, most good things that happen in groups of people. I mean, if you go and watch most inspirational talks, you'll see people say things like, you know, no one has ever really accomplished anything incredible on their own. You know, that's quite a generalized statement, but it's kind of true. You know, you look at anything you consider to be remarkable or inspirational at a large scale, you know, whether it's something like SpaceX or Google Maps or some kind of software or software-related system, and in nearly all cases, it involves large groups of people. So we're going to be talking about how to actually make you scalable, how to make you work with other people effectively, hard skills, soft skills, and everything in between. And as I said, we're going to be talking about Python, the main programming language in the course. We do teach Python in this course a lot, probably like a quarter of the lectures are on Python, quite a bit, though I don't want you to get the impression it's a Python course, as opposed to, say, COMP1511, which is essentially a C course. So it is a little bit different. Don't kind of think of this as COMP1511 with Python. That'll get you out of sorts, but you know, we are going to teach it, and some fun web stuff. So basically, we'll help you build some little websites, web servers, and it'll be a lot of fun. This course covers more breadth than what we needed to do in COMP1511. And because of that, what you'll notice in this course is that we do have multiple topics. They are running together. They are interlaced. For some of you that are kind of used to a few more structured courses, this one is a little bit more dynamic. It's set up like that. It's good like that. And we've tried to make it really clear, you know, when we're going to be talking about software engineering, when we're going to be talking about Git, when we're going to be talking about Python, because we will be talking about multiple things every week. And the rationale behind that is simply, if we were to teach these things sequentially, you would have a worse learning outcome. That's our professional judgment. So, I've kind of touched on this already. This is just I answered this the other way around, just around like what the main differences are between the courses, just because I think that's the one common denominator, right? Is that most of you have done COMP1511. I guess you have to have been here. So that's an easy comparison. Now, in terms of the relevancy to your program, if you're a computer science student, then you've kind of come from COMP1511, or I believe there's a bunch of people who've come from 1911 as well that I've been approving. This is quite specific to computer science students. So your computer science degree after, you know, first term, first year, kind of spans off in 3 different directions. You've got your COMP1521, which a number of you have done as well, which is really like low-level systems. It's halfway between software engineering and electrical engineering, you know. It's what software would have been 20, 30 years ago. That's not in a bad way, it's just a lower level kind of thing. You have your 2521, which is your data structures and algorithms. That's there to make you think like a computer scientist. And then you have COMP1531, which is, again, the beginning of your engineering journey. So Courses that have COMP1531 as a prereq assume that you have learned the basics of software engineering. One thing that's also super exciting this term is that we can say welcome to 130 at least of our mechatronic friends. What's exciting about T3 of this course is that as of 2021, COMP1531 is now compulsory for mechatronics programs, if I believe. So what that means is that we have a lot of people who started a degree this year and started in mechatronics, and now that they're in their third term, they're here. So welcome to the School of Computer Science. Obviously, I guess you've done 1511 if you're here. I guess I haven't looked at your program, but so you're probably not that new. But yeah, big shout out. Ask people, when you meet people, ask them what they study. There's a lot of interesting things to learn about. I started studying mechatronic at uni originally with computer science, but I dropped it because I suck at mechanics. So nice to see everyone here. In terms of assumed knowledge in this course, which is a question someone asked earlier, we simply assume that you've done 1511, and what we assume is that you are essentially a mediocre C programmer, that you understand if statements, while statements, ints, doubles, the basics of abstraction, functions. And testing here, actually, I really should remove that because testing has progressively become a less critical part of 1511 to the point now where we kind of don't assume you know it at all. So you can kind of ignore that last point. Yeah, that's the assumed knowledge in the course. Okay, so we say that software engineering is critical. We say that this course is about software engineering. We say that we're going to help you become a better software engineer, or at least start that journey. But some questions that always come up around this are, what the hell is a software engineer? What's the difference between a computer scientist and a software engineer? And in the UNSW sense, which is kind of the thing you all think about, even though it's not super relevant, it's like at UNSW, we have a software engineering degree, we have a computer science degree, and some of you are studying software engineering, some of you are studying computer science, and you're like, what's the difference between the two? At UNSW, there's some quite literal things that are different between it. Like, software engineering has 60 days of industrial training. Software engineering has a compulsory honors year, and things like that. Though the more kind of obvious hit, because you can solve those things with computer science, right? Like I did honors as a computer scientist. I did industrial training as a computer scientist. It's like, because I studied computer science, it's like they're all the same thing. The main difference is that a software engineering degree at CSE has more courses that are kind of quite specific to software engineering, and computer science students have more electives. So there are more software engineering courses which focus on things we're going to talk about in this course. Some more project stuff, some more teamwork stuff. Though fundamentally, they're all kind of the same too. Never in my life have I seen anyone who at least studied at this university be kind of discriminated against the kind of job they can get because of their choice of studying computer science or software engineering, or in many cases, to our mechatronic friends again, if you're a competent enough programmer, I rarely see even that being a big difference in terms of the opportunities you can get. At least in tech, I think obviously in kind of boring old classic stuff, they get a bit more funny about it. Like, I don't know, if you went to Deloitte to be a software engineer, I don't know, not Deloitte specifically, you know what I mean, like consultancies and stuff that aren't just hell-bent on software. But short answer is it doesn't matter. Doesn't matter what you do, as long as you know your stuff, you're pretty sweet. That's a very UNSW-focused understanding of it, though. But I want you to all think for a second that you're all essentially software engineers. I don't care what's on your program. I don't care if it says mechatronics, software engineering, computer science. You're all effectively software engineers, or you are aspiring software engineers, or you should aspire to be software engineers. The formal kind of way we want to think about it is that software engineering, which is something that software engineers do and in theory defines them, is, to quote the very big piece of text here, the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software, and the study of these approaches. That is the application of engineering to software. And what that means in practice is that we're going to build thought-out, testable, scalable software that meets the requirements we set out and is easily maintained. We want to build good software because it's easy to write software. It's hard to build good software. It's hard to build software that's easy to scale. It's easy to write more code. It's easy to make changes. That's the hard part. It's hard to, it's hard to have software that actually solves the problem, and that's things we're going to be talking about in week 3, for instance. So there's a lot to this topic, but it's really just about writing good software. Oops, sorry, clicked down on the wrong window. And it's all well and good to describe what software engineering is, and hopefully it makes sense again. The thing about software, to take a step back, is that in normal engineering, it's kind of easy to think about what the engineering lifecycle is, right? Like at least you think about that. Like think about, mechanics, right? Building a plane. Okay, well you have to sit down and figure out what the plane needs to do. Then you have to figure out, how you're going to design it. You make it up on a computer, and then you go and build it, and then once it's built, you have to test it to make sure it can, fly, and then you give it out to people, essentially. And then there's maintenance involved, and you have to keep starting again, and you have to keep going, okay, well, there's more problems we have to solve, there's more we have to integrate, stuff like that. It's really easy to think about that in a tangible way. At least that's what I see with students, right, is that students kind of get these engineering principles on a larger scale. It's quite intuitive, but so this last line here about it's the application of engineering to software is really what we're getting at. It's about taking those same conceptual ideas and simply applying them in the landscape of software programming. So why does this matter? We understand what it is. The main reason, you would read different answers about this depending on where you read or who you talk to, but the main reason I think software engineering is important, right, is because you can say, okay, well, why does good software engineering practices matter? Okay, and someone says, well, it helps you write better code. Okay, sure, but why does that matter? Or it makes sure your code's tested. Why does that matter? So your code doesn't break. Why does that matter, right? Let's dig deeper into that idea of why does any of this stuff matter? Because while the shallow answers of it stops your code breaking, it makes it easier to maintain, all of this stuff realistically ends up coming back to a pretty simple concept that most software you're involved with is written for some kind of business or organization, university research, private sector companies, that have an interest in making sure that your software is not consuming an unnecessary amount of time, costing an unnecessary amount of money in terms of paying people, and doesn't have certain errors or reliability issues that cause grief, right? Like Web CMS 3 is down. That affects your opinion of it. We force you to use it. You're not a consumer in the market. Therefore, it doesn't matter in this case, but it's like, imagine if this was YouTube and YouTube went down an hour a day, right? That wouldn't be okay, and people wouldn't use it, and therefore the people who are essentially paying you or you're working for, or you if you're working for yourself, right? It's not good. So what we like to think about is that good software engineering principles are a way that businesses can essentially de-risk themselves. It's how they can take risk away from things, because you get a well, how would you put it? You get a well-written piece of software and a piece of junk that some programmers hack together. Both of them could generally work, but one of them's actually going to do good things for the broader picture. So we're interested in this primarily because it helps de-risk projects we're working on for time, for money, whatever it is. It doesn't need to be profit motivated, because pretty much every piece of software you build has an underlying need to work for the stakeholders you're giving it to. A lot of different scenarios, but that's pretty common. You want the software to work, and you want it to be cheap and easy to maintain and grow and edit and everything else. That is like a fundamental constant. And there's lots of reasons why we care about this stuff. I've got a link in the slides here, which are 11 of the most costly software errors in history, right? And you can go read through this. I'm not gonna dictate this to you, but here's an example. A lot of this stuff kind of comes back to testing primarily, but there was the 1998, I don't remember the details of this off the top of my head, but there was the Mars rover that got lost because people failed to convert units to millimeters and stuff, inches to millimeters, inches to centimeters, because you have these multinational teams all working together with different units trying to integrate different software projects, right? Because again, you don't just have a whole bunch of people in the same country working on these massive things. You're often having very different software systems from different parts of the world being pulled in, and they might use different standards or metrics and stuff that could be solved with some simple testing. So there's lots of cases where you're like, wow, it would have been really prudent to invest more into making sure this stuff works, which is the case here. Okay, getting onto some more specifics about the course. In terms of assessment and like how it's broken up. Because this first hour is really just about us talking about the course, what it is, why it is, and what's involved in it. The assessment structure of this course is medium complexity, right? There's more complex courses and there's simpler ones. Essentially, your mark's made up of three big components. It's made up of your class mark, and we'll talk about the detail of this, which is 15% of your mark, and this comes from tutorials and labs. So the time you spend in tutorials and the time you spend in labs, we'll talk through that in a sec. Well, in a couple of slides. That's 15%. We call that your class mark. They're easy marks. They're designed for a middle tier student to get full marks in. Okay, they're your marks to lose those ones. They're really there as an incentive to keep you learning and going along, and they're not worth a ton. They're just there to really keep the lights on throughout the course so that you don't fall behind. We have a project mark, which is 50% of the course. This is a group project, which we'll be talking more about in a couple slides again, which is made up of 3 iterations. So essentially your group project, 10 weeks, 3 big chunks of it, and that's working with people. So that's the bulk of what you're going to be doing in this course. The exam is 35%, and that is essentially going to be a 3 to 4 hour programming exam with a little bit of theory. A lot of Python in that exam. Someone said in the chat already that exam component's tiny. We actually think it's quite large. I think, we've seen ever since the move to online teaching, exams aren't really as useful as they used to be, because their main use was getting you to sit down in a room so we could tell you aren't cheating. Frankly, that's why we had exams. That is no longer really a thing we can do. Therefore, the intrinsic value of exams has kind of dropped pretty significantly. So 35% is low, I guess, compared to maybe a maths course or something, but we still think it's too high. So, I mean, not for you, that's not going to change, but, in future it will. And I think other courses should get on that trend too. So, if other courses have exams that are way too high weighted, just particularly if they're open book, I want to stress, if exams have really high weighted open book short time exams, then tell them I said that's needs some thought. And yeah, let's get into the details of these assessments. So the course covers a whole bunch of different areas of teaching: lectures, tutorials, labs. You got your major project, your exam, and the other thing we didn't talk about was help sessions, which are essentially consultations, drop-in clinics, whatever you want to call them, where you can get some help throughout the course outside of your scheduled class time. So to talk through these, your lectures are lots of 2 hours a week. Most of you watching this know this because you found it somehow. But the two main things to point out on WebCMS3, which I hope is great, it's working now, is that on WebCMS3, you will see that you have a timetable section and a coursework section. So the coursework section is all about your marks. It's all about the work you do. It's where we have the content. It's where you find the material. The timetable stuff is all just like logistics operate. It's just where you find out the time and place of things. There's no actual content in that section. So lectures, for instance, the timing of lectures you can see here up the top. It just tells you the times and the dates and the link to this live stream that you're probably watching right now, unless you're watching the recording. But all the content, all the actual recordings of lectures, lecture slides is on the coursework page. And you'll see on this coursework page that, oh no, rogue HTML. You'll see on this coursework page that all the lectures and links and recordings will be posted here. And in fact, after this lecture's over, you don't need to worry about this link anymore, because what we do in this course is that even though we have 2 hour lecture slots, we do a lecture for as long as it needs to be. Sometimes we'll have a 15-minute lecture or a 70-minute lecture. This one will finish up before 11. Yeah. And then we move on to the next one. So what happens is while you watching live or seeing these 2-hour lectures, people who don't watch live, typically, and yourself, if you ever want to watch it later, we end up having the recordings over here, broken up. And the reason we do this is because I think we've seen a bit of long-standing feedback from students that when you break up lectures in a 2-hour slot, irrespective of the topics in them, it's very hard to actually go back and see what something is. You can use YouTube timestamps and whatnot. That's totally fine. Like, we could do a few other things, but it's just, I don't know. I don't like it, frankly. I don't like having lectures which students intend to watch by topic broken up by time. That seems dissonant to me. So that's why we have this kind of lectures page. That was a bit of a ramble. We upload the recordings there. The internet where I live is crap, and because of that, lectures will take like 2 hours to 3 hours to upload. So if you see a lecture like today, expect it to come up in the afternoon. So if you wake up at 11:30 and you're like, oh crap, I missed it, you can watch the live link. It's still going to be there, but you don't. If you want to watch the breakups, they'll take a little bit longer. Cool. Tutorials and labs. Okay, this stuff's really important because it affects your class mark. So let's talk about your class mark really quickly. If you go to the course outline, oh yes, I didn't get time to put this slide in this term, but I wanted to do this. So quick segue. At the top of the course outline, you will see a little welcome message from our team, and you'll also see 4 bigger faces, which includes Emily, myself, Jake, and Nick. So the 4 of us are essentially, we're all teaching staff members, but we have some extra responsibilities between us. So Jake and I are lecturers in this course. In this particular term, Jake will be doing some of the lectures in week, I think, 4 and 5 and 10. So you'll see a little bit of Jake throughout the term. He's also a tutor and lab assist in classes this term. So some of you will see him this week, tomorrow, I believe. New CSE staff member, full-time education focused person. I believe that there's a CSE soccer running an Ask Me Anything tonight, Wednesday the 15th of September, from 6 to 8. So if you have Facebook, search CSE Soc, find the link, and drop in and learn a bit more about Jake. We also have Nick and Emily. Nick and Emily are experienced COMP1531 tutors who have helped develop, in the case of Nick, some tutorial and lab content this term, and in the case of Emily, helped develop more parts of our major project. So if you have questions throughout the term on the forum about tutes or labs, specifically labs, or you have that, you'll see more of Nick, and if you have questions about the project, you'll see more of Emily, but you'll see all 4 of us around helping make things happen. I don't know why I have a white box. That's terrible. That used to be something better than that. Very, very uninspiring. So we're talking about the tutorials and labs in the course, and if I go down here to our class mark, sorry, if I go down, further down. So your class mark in this course is made up of 15%. Now, if you've done this course, you've done 1511, I believe, so you should be familiar with the notion of a 1-hour tute, 2-hour lab. That structure exists in this course as well. The difference is that what happens is that all of your should really just use this. All of your class mark is made up of 15 marks in total, right? Which is 15%. But what happens is that there are 10 marks, 10 total marks you can get for labs, and there are 8 total marks you can get for tutorial attendance participation. Right, like that. That's pretty much it. So what that means is that the total marks you can get is 18 marks, but we cap it at 15. So what that means is that there are 18 possible marks to get across tutorials and labs, but you only need 15 of them to actually get full marks for the class mark. Which means you can get 10 marks from labs and 5 marks from tutorials. You can get 8 marks from tutorials and 7 marks from labs. That's totally up to you. And a big thing we're trying to do more and more and more is give you more choice in how you approach your own assessment, particularly for the class mark. Now, in terms of those marks, your lab marks out of 10, as I just said, and what that is that's 1.25% or 1.25 marks, however you want to think about it, per lab. And we have 8 labs in the course. Lab 1, 2, 3, 4, 5, 7, 8, 9. They're the labs we have. You get 1.25 marks if you do enough lab questions. Very quickly, in each lab, what you'll see, if we go to the tutorials and labs page, if it loads for us today, you will see on lab 1 that this, let me log into GitLab. You can just log into GitLab if you haven't already with your Z number and Z ID. You'll see that in this particular lab, there are actually 5 questions, 5 different lab exercises, like, tasks, if you will, smaller ones. And you can see each of those has a certain number of points associated with them. And what we say is that for this lab, you need 4 points to get full marks. You need 4 points to get full marks. So what this means is that you only need to do 4 out of 5 of these exercises to actually get full marks for this lab, to get that full 1.25% of the lab. So there's a little bit of, I guess, access to this stuff. Like access to like easy marks here if you want to. So there's choice. You can choose to do more of one week. You can choose to do which questions you want on a given week. You can choose which labs you want to do. Like we give you the flexibility that if something goes wrong in your life, or you just aren't interested in something, or you have a really bad week, you have some control to actually change that stuff. In terms of your tutorial mark, which is out of 8, there's 8 tutorials as well, so it's quite simple, 1% per tutorial. The way you get marks in that tutorial, you essentially attend the tutorial, have your webcam on, and engage in some way. It doesn't have to be talking. You can actually just type. You can just type in the chat, right? Now, and again, to address like the natural elephant in the room, there is this always comment about like, what if I don't want to put my webcam on, or what if I don't feel comfortable with putting your webcam on? If you have any severe issues with that, you can email the class account. We'll tell you what that is in a sec. Though, generally speaking, what we'd say is like 90% of students just put their webcam on because it's easy marks, right? It just gives a little bit more on your tutorial attendance participation mark. If for some reason you really don't want to do this, then you can essentially just do other lab exercises. In fact, several dozen, 100 plus students, I don't know, like pretty much anyone in this course who doesn't have their webcam on can still get full marks in all the other areas. The main reason we do this though is because tutorials are far less crap if you do that, right? So if you attend a tutorial with your webcam on, they're more fun. This is the feedback we've had from students for 4 terms. Rather than just sitting there staring at an empty screen, you're actually engaging with everyone. We wouldn't make this a thing if we weren't confident that it was well received. And we know that every term in a class of 25, there's a few students who just don't want to. People are always asking me, I don't own a webcam. If you don't own a webcam, join the tute with your phone as well. Put your headphones on, join the tute with your phone. You can join it with your laptop too. You can join with 2 things. It's very doable. It's very doable to kind of be part of this and be engaged and talk to your tutor about it. If there are severe issues, then please reach out though. Though generally speaking, it's easy marks. One way I want you to think about this, because I think this is very important, is that we aren't saying that to get marks, you have to do this, or blah, blah, blah. If we were to take this requirement out, the assessment would be the same. You would just have to do the work elsewhere. What we're saying to you is that if you would like to have less pressure participating, as in typing in the tutorial, or if you want to do less lab exercises, or if you want to skip more lab exercises, an easy way you can literally do that is actually just get free marks by attending the tute you're already attending with your webcam on, so that people actually feel like you're part of a learning community with them, which is a lot better. So it's not so much like this horrible requirement that if you don't do, horrible things happen to you. It's literally saying you don't have to do it, but if you do, it's the easiest marks you're going to get in the course. And you can skip out on other things. And even if you don't do it, you can still get full marks. Easy. Tons of ways to win on this particular front. Okay, I've talked about that for way too long. In terms of labs, labs are due typically the following Monday. So we have a week 1 lab due this week. And what that means is that's going to be due on Monday of week 2. And then you need to show or demonstrate that to your tutor during week 2. So start of week 2, you just kind of show your tutor that, and they will, give you the marks for it. Submitting it does not give you the mark. It's just like, it's the actual getting it checked by your tutor that gives you the mark. So that's important. Your major project, groups of 4 or 5. So this is a group work course, 9 weeks. We will be posting information about your major project on Friday night. So essentially what happens this week is that in your tutorial, your tutor has a list of students in their groups this week. When you go to class during the lab time, they will help organize you into groups and finalize your groups and get you set up with Microsoft Teams so you can all communicate. They'll get you set up this week. And then on Friday night, after we've done all the classes this week, we will release the major project for you, and we'll send an email out about it so you can see it. And then that's kind of how it begins. All the information about the project will be as part of the, in the release, and we'll also have a pre-recorded video there to give you a bit of an overview in it too. Vandana says, can we show our labs in the same week rather than the next week? You usually can't. Some tutors will be happy to, though tutors have been told that for like efficiency purposes, it's just easier to mark everything in 1 week. So generally speaking, not really. Groups have already been allocated based on the preference forms we filled out. If you have any group issues, you can talk to your tutor about it. They're the ones sorting all that out. If they have issues, they'll come to me. So if you have any group related issues at this point, you talk to your tutor. Don't email me because it just won't be as helpful as your tutor. They're great. They'll sort out all of your problems for you. I'm getting some other questions in the chat. I won't be able to address them all, but a lot of the questions being asked are actually written down if you go and read some various things. But generally speaking, yes, you're going to be using Microsoft Teams for communication. Submitting works. We'll talk about Git. Submitting won't make much sense until we talk about Git. Pratik asks a great question though. Is watching the recorded lectures on YouTube equivalent to watching these lectures? Yeah, it is. I hit record right now, and then when we're done this, I hit stop, and then I hit record again. It's literally just a logical cut. Yep, so that'll be released on Friday. Help sessions. If you want extra help, you can head to this link and you will see a whole bunch of sessions throughout the term where you can actually drop in and ask questions. If you have problems with the labs, if you have problems with the project, you can just come and drop into one of these sessions. They're all at different times. During busy periods, we have more people. What I would say is that with these sessions, we don't, like UNSW does not resource things so that we have a tutor for you whenever you need, right? There is a queue with these sessions, like an actual queue where you queue up and stuff. Go to these sessions with something to do, because you might have to wait, sometimes 2 minutes, sometimes an hour, but go there with something to do. Don't go there being like, I can't do anything until I get help. Like, go there with something else, like folding laundry. It doesn't matter. My point is, some students get kind of angsty when they have to like wait half an hour, which is understandable if you've come to the help session being like, I want help right now. So just come to these sessions knowing that sometimes you might have to wait, and that's totally okay. That's just the nature of it. We can't predict the supply and demand of help sessions. Sometimes we have too many tutors there and they're like, I'm bored. And sometimes we have too many students and we're like, whoa, that's crazy. So yeah. And then the exam will be releasing information like in week 8. There is no hurdle for the exam. It's not a double pass. Many students, well, a reasonable handful of students pass this course before the final exam. And many others only need to score like a 20% in the exam to pass the course, which is great. So, and the question was, can you watch past terms lectures? I probably wouldn't recommend it. We are making some changes this term. It'll be relatively indicative. Okay, and in terms of getting help in this course, here's the hierarchy for you to get help if you want to get help. So the first thing you do if you want to get help is you go talk to your team, because most of the problems you're going to have in this course are going to be related to the project. You're going to have lots of questions about the project. So when you ask a tutor, you know, hey, this thing isn't working in my project, the first thing they're going to say to you is, have you discussed it with your team, and what would, like, tell me about how that discussion went, right? And that'll be the first thing they ask. After that, you can go to the Ed Forum. The Ed Forum is on the sidebar of WebCMS3. You can find it right here. You can just click Forum. It'll take you to the forum. If you didn't get signed up, you will get signed up automatically. You can just register straight away. That's where you'll get most of the help. There's no step 2 apparently. Oops. If you can't get help on the forum, if things aren't working for you getting help there, you can always attend a help session, which we've just talked about. If that doesn't work, then you can email your tutor or lab assist, though generally this is getting like into the more like personal matters and stuff. And if that doesn't work, you can email me and Jake at cs1531@cse.unsw.edu.au. I can't stress this enough. Don't email me directly. I will get to it, but it'll be slower because of the way I have a lot of things to deal with, and I filter these emails as a higher priority. So if you email this, there's both a higher chance that I'll get to it quicker and Jake could get to it as well, right? So please email CS1531. In fact, that is just Jake and I. So it's like even sensitive issues, please feel free to email that. Because I'd be working with Jake on all this stuff anyway. So that's where you email if you really need some sense. Max says, if there's confusion on the project specs, then can tutors help clarify it for us? Yeah, for sure. They definitely can. All we're saying is that make sure you've talked to your team and check the forum first. Like there's a certain expectation we have on you that you take some personal responsibility of trying to solve a problem before you come to someone saying, you know, I need help. But that's why we generally say the forum. The forum's great too because it's everyone can see your posts if you make them public, so other people get to benefit from it. All right, getting to the end of this one. In terms of getting set up in this course, getting ready for the course, you can use any operating system you want. It's a very straightforward course. You can use the CSE machines or SSH with VS Code. That's totally fine. You don't need to do any setup for that. You might be familiar with that from COMP1531. Or you can use Linux, Mac, or Windows. If you use Linux or Mac or OS X, it's like you will have a pretty easy time because it's a Unix-based system and most of the commands you can install pretty easily. We don't specifically support all the setups because every one of you have different computers with different prior installs and different problems. So, you know, you can go and set that up yourself if you want, even though it's relatively simple. If you're on Windows though, you can install the Windows subsystem for Linux. We have some information about it on WebCMS3. This is what I use. Throughout this course, I'll be using a mix of Windows locally, because that's what I use on my computer, as well as VLab predominantly for the stuff I show you. So it's totally doable to use Windows. If you haven't installed WSL and you're a Windows user, it's something that I would just strongly recommend that you do it. I'm not a big opinionated person when it comes to software though. It will change your life because it will essentially expose you to a Linux environment without the need for VLab or a virtual machine or something similar. You can totally use VS Code. That's absolutely fine. Your setup for 1511 will pretty much get you there because VS Code with SSH is connecting to the CSE systems. Oops. Yeah, so super easy. In terms of the other setup, we've also just listed out some of the core kind of technologies we use in the course. We use WebCMS3, Ed, we've talked about that. We've talked about Teams. GitLab we haven't talked about, but we're about to. Help sessions we run on Collaborate or Moodle. That's super easy to find. It's the only thing we use Moodle for. In fact, you don't even need to log into Moodle, to be honest, because the way it's been set up here is that we just have a link to join. We just have a link to join the help session. You don't even need to log into Moodle. You can just click on that link and you'll go straight to the help session. It'll ask you for your name and then you just join. Super simple, right? Really, really simple. So don't be daunted by this kind of list of things. Most of it's quite straightforward. And in fact, the only actual setup you probably need to do is probably to install Microsoft Teams. I think you can also use it on the web browser, though it's a little bit nicer if you have it installed locally. In terms of software that we use in the course, the only two real big pieces of software are Git and Python. you can go and install those. They're already installed on the CSE machine. So if you're using VLab, you don't need to do anything. If you're using something else, you need to install them. We have some setup instructions. Again, they're really easy to install, so don't even worry about that. In our last 5 minutes before we take a break and get stuck into Git, what I want to quickly talk about is just a preface, is the software development lifecycle. We're not going to be going into any detail with this, but we want this to be clear in your mind from day one. In this course, we have a whole bunch of lectures that are on the software development lifecycle. You can see here, any lectures with the dog emoji is about software engineering and the software development lifecycle. And all this really does is dictates the actual life cycle of a software project, where we start at the yellow square jigsaw piece, and we move from requirements analysis to design to development to testing to deployment to maintenance and then back to the start again. So we're essentially moving in this, kind of endless cycle of iterations and improvements. I can see everyone's getting the classic year 11, 12 IPT, HSC flashbacks. Thankfully, I didn't ever do that in high school, luckily. So to quickly touch on them, requirements analysis is the idea that you need to understand the problem you're trying to solve. I always tell people that, requirements analysis is basically just figuring out what you're trying to do. It is, I would say, the most important part of software engineering without doubt, and it's understanding the problem. If you're trying to, let's say you're trying to buy a new bed, for instance, in your bedroom, you do this kind of thing all the time. You got to figure out how much space you have or how much space you need. You got to figure out how much weight you're going to put on it to figure out what you're actually going to use to solve the problem. You have to figure out what your needs are in terms of, softness of a mattress or something. Like, it's really understanding the scope and the constraints of the problem you're trying to solve, so that when you go and solve it, you're actually solving the right problem. Because if you aren't solving the right problem, then, you're going to just give the wrong solution. You see this kind of thing all the time. We're going to talk about this a lot more in week 7. Why are we talking about it in week 7 if I just said it's probably one of the most important parts of the course? The reason is because this is very theoretical, and because the project is not open-ended, we can't actually get you to do a lot practically with it yet. So it's a matter of timing and logical placement, but we do talk about it a lot more in detail later, and it's a really interesting topic. It's one of my favorite theoretical topics. And again, you've come across this all the time. What problem are you trying to solve? We get this all the time at work. We get this all the time in other contexts. Someone comes up to you and says, I have an idea. Let's hire a car to do this kind of thing. We need to move this desk. Let's hire a car. And, someone just says like, what problem are you trying to solve there? You book a car because you think the problem you're trying to solve is hiring a car. But if the problem you might be trying to solve is to move a desk or to move, some stuff, and it's like, maybe there's a different solution to that problem. Maybe there's a more efficient solution. So if you don't stop and start with the whole why and what the hell am I doing, why does it matter, before you even start thinking about how to solve it, you're going to always end up with terrible solutions. So requirements analysis is a huge part. We'll talk about that in a lot more detail in week 7. But for now, just kind of trust me that it matters. Design is something we don't need to chat about much. We do some lectures on good design. Design is a way of trying to create good software before you write code, right? So I've got here, it happens ideally before you write any code. You've kind of done this already in potentially some other courses. If you've ever written pseudocode, if you've ever thought about how to write code or got a pen and paper before you actually started writing programming, that's good design. Design's really important because once you start writing code, there's a good chance things are going to get uglier. So you want them to be as thought out as you can before you put your hands on the keyboard to actually write some code. We're going to be talking about how to schematize, make schematics for your work, draw diagrams, think about certain very simple design patterns, good principles to follow to make your code prettier. We do talk a little bit about programming throughout the course, so there's not much to do there, because kind of 1511 is the development part of the software lifecycle, right? It's like write the code to do the thing. A massive part of the course that we're going to talk about ASAP, probably tomorrow, is testing. And testing is making sure your code works. And we're not just going to be talking about how to write tests, we're going to be talking about how to automate the writing of tests. So that when you're running tests, you don't have to read printfs and stuff. You can actually just run it and it will just output and say, yep, you did good, you did bad, you did 90% good, go check on these things. So the automation of testing, how to write good tests, philosophically, like what are good tests, these are all things we'll be talking about and are a big part of the course. And then the last parts of it are deployment, which we talk about in week 8 or something, I think, which is how do you make your software available for use? When you write an application, how do you not just finish it, but how do you actually give it to someone? You know, it's all well and good to write it. Like, who remembers another programming course? It's all well and good that you made something, but how do you share that with 1 million people? You know, because software doesn't just exist in a vacuum. It needs to be delivered to people. So we're interested in trying to make things available for use. And then we have the maintenance step, which we talk about very little, which is really just about analyzing your work and reassessing the requirements. Because in most software projects, once you've actually deployed something, you know, you've figured out what you're building with stakeholders, you've designed it, you've built it, you've tested it, and you've released it, the next thing to do is actually talk to them, track them, analyze what's happening, and say, actually, we might have gotten some things wrong. Let's start again, let's keep learning. And that's where the iterative process all comes in throughout the software realm. In this course, this is the rough order that we'll be talking about things in. Again, ideally, it would be great to talk about it in order, but with the content we have in trimesters, that would be very challenging. So we spend a lot of time talking about testing at the start, and then we do a lot of coding and design, and then later in the course, we come back to both requirements and deployment. Now that you've done some stuff, we talk about, okay, how is this all meant to have started, and how is this all meant to have ended? And then that's pretty much it. So what this is this is the end of our first lecture, 1.1 on the lecture deck. We're going to take a 5-minute break now because I said, I guess. We'll take a 5-minute break and we'll get on to 1.2, which is about Git, which is super important for your first week and functioning with your team. So what would be great is at the end of each of these lectures, if you have your phone out, unless you're on your phone because you're funny like that, just take a photo app, quick scan of the QR code. It'd be great if you could leave feedback. Literally, you just click on the lecture and give it a rating. You can add more info if you want, though generally speaking, it's just great to get little nuggets of information. We did this in T1, and we used it to figure out what lectures need more love and attention this term, and we'll use it this term for more love and attention next term, and we'll use it to know what we did better and worse. So if it takes a minute, then that would be great. Well, it does take a minute. That would be great.